Nobody.
Yeah, nobody.
Nobody showed up.
Yeah.
They're scared to death. That's and run away.
I don't know why. There is no other email.
No, just check and no.
Oh yeah.
So yeah. Because yesterday I went.
Yeah.
Where are you from? China?
From South Korea.
South Korea.
Yeah, not North Korea. Yeah.
Are you doing a master?
Yeah, I'm here to get master's degree. My first semester. Hi.
We need to send somebody down to third floor.
I'll go check down.
All right, would you do that?
There's like 7 lectures for this class.
Hmm?
Oh, I was trying to print
Oh.
out lectures, and that's only like 7 of the 27.
Made me forget where I was in my password. Oh, this is a much better classroom. It pays to have friends. And I don't think we're going to get disrupted here. How old is your son?
Sorry?
How old is your son?
I have 3. 15,
Oh.
14, and 6.
Yeah. 3 boys.
2 boys and a girl.
Ah, okay. That's good. You gotta have a girl.
Yes.
Buenos dias. It's almost bonsoir. So forget to shave?
I will.
Me too. Shaving's the stupidest thing that was ever invented. My visits to Iran, they shave like once every 2 weeks or something like that. That's about right. I like that. Hmm? In Iran. Iran. In Argentina, they don't shave unless Christina says so. It's a joke. She's going to lose, huh?
I hope so.
It's going to be close. Her party did not do well.
No.
It's amazing. And how is Mr. Holland doing?
Not too well, I guess.
Sorry?
It's not too well.
It's going into
Into war?
Syria.
Into? Syria?
Yeah, maybe. I think Great Britain too.
Really?
Yeah, the Prime Minister just asked the Congress to take a decision quickly.
Have you ever been to Syria? I went to Lebanon once. It's a mess. The best advice is don't get involved. And that's from an American. You should be telling me that. So this buddy of mine that owns this software company in Sophia Antipolis, he says, we told you. We gave you all the help you needed in the Iraq War. We told you not to do it. And that's nice. I appreciate that. Okay, I got to get everybody's name and face connected. Avery.
Yep.
Matthew. Okay. You want to go by Matthew or Hughes or Marie or Desconte de Pilon? Sorry?
Matthew is perfect.
Okay. I got a little bit of news for you, okay? I always take Matthew,
Yes.
or Matt, and I make it Matty. Yeah.
Why?
I don't know, it's just my brain. It does it. So from now on, you're Matty.
Alright.
I like that. Gautier. Okay. You go by Gautier?
Good to guys.
Yeah. I think I'm going to call you Louis. After Dreyfus. Yeah. Papillon, you know?
Well, I've said
Yeah. Okay. So what does your mother call you? Ga. No, that's him. One of you. Yeah.
She's called Gugu.
Gugu? Oh, you should have told me.
That's even better. But it was God with a D. Okay.
Oh, we didn't hear that. I like just Ga.
God is what my mother called me.
Yeah.
You look a bit like my mother, but different.
I look like your mother? Okay. I'm not sure what to say about that. You're not related to Olivier, are you? De Brule. De Brule.
Ah, no, I would have been.
Yeah.
But I don't believe it.
Yeah, you're probably lucky that way.
How come you know?
We know everybody. It's a small world. You don't believe it's a small world?
I don't know.
You'd be surprised. Get the door, will you? Oh, I get it. If your card works. I don't know. I mean, I know my card will work. It's all right. We're just introducing everybody. Okay, which one is Farid? I'm guessing. Yes, okay. You want to be called Sayed, Munib, Ula?
Smart Putu.
Sorry?
Smart. SMU acronym for my name.
SMU? SMU.
SMU.
F? Smuff.
Yeah.
Would you talk to him after class? You might not want to use that. I
That was
forget.
too close to something that's really bad.
It's all right. So, how about if I call you Smurf? You know Smurf?
Yeah.
The little hat? Yeah? Okay. You don't like Smurf. You'll call me worse things than that. Jorge, what do you want us to call you? No, we're going to call you Georgie. Okay. Santiago, you're too old to pick on. What do you want us to call you?
Santiago's fine.
No, we got to come up with a nickname. While we're still young.
My young nickname was Cuchufo.
We ain't going to go that way. Where were you born?
Argentina.
No, what city?
Buenos Aires.
Oh, okay. It'd be better if you were born somewhere, without such a nice name, like Comodoro.
Well, I have lived in Comodoro.
Yeah, I know. You can tell everybody later about Comodoro. Okay. And when they tell you you're going to Argentina, make sure you ask where. Okay. Mr. Kim. Okay. And how do you want us to call you?
You can call me John.
John? Like my son, John? Yeah. Yeah, I also call my son lard head, lard butt, get a haircut, wash your face. No, you don't want to, just John, okay. All right. And, another one of these French names. Mr. Lacan. Lacan? No, it's my Louisiana French, okay?
Cajun French.
Yeah. We would say Lacan in, yeah. You like that? Well, let's see what your initials are P-A-M-P. That's Pamp. If only your middle name was Ignacio or something. But all right, so we're going to call you Pamp. You know what Pamp is in this country? Pants.
Yeah, I know.
Pampers.
Oh,
You know Pampers?
yeah, I know.
Yeah, good.
I'm okay.
Yeah, you're good with that, okay. And Miss Lee, how do you want us to call you? KJ? Okay, Kong J, all right. Mr. Song,
Yeah.
we gotta come up with a good name for you.
So,
Okay. Nothing else? Chuan? Chuan, yeah. You like that better?
yeah.
What does your mother call you?
Wani?
Wani. You shouldn't have said anything. Okay. Where's Mr. Wang? Session? How do you want us to call you? You're Wang, right? No?
No.
Are you in here?
I didn't.
Sorry?
No, I'm not in.
Are you going to register?
I know. I didn't register.
Are you going to register?
I cannot because I'm full of time.
Okay. All right. Well, we'll talk about that afterwards. So I don't know where this fella is. Okay. I guess we'll cover that later on. Okay, so our numbers reduced a little bit. So now we're going to have fun. There's a deliberate scheme in my mind. We're going to have a good time, all 12 of us, or 11 now, or maybe less. This is going to be good. I've decided. I've decreed it to be so, therefore it shall. So we left off, and I understand that the video didn't work, right? Did anybody look at the video? It was corrupted, apparently. I think all of them were on Tuesday. So, not that you're going to look at the video, but hopefully this one will be good. So that was why. Last night I was going to do a repeat for this, but, and I apologize. I've never, ever missed class. But I sat through traffic for 1 hour to go 1 mile. And I said, this is insane. And I called Ted and I said, I think I can make it. And then I looked at the clock because I didn't realize I'd been there an hour. Forget it. So, sorry, my apologies, but
Which
it was on Interstate 45. It just was it was something unusual. It had never happened before.
I thought if you're coming from downtown, you just have to take the Hardy Toll.
No, but this was it just was a clog. It just, whatever it was, it just would not go away. I know Buenos Aires traffic is worse. I know Paris traffic is worse. I know Korean traffic is worse, but, okay. We don't tolerate traffic very well here. So, anyway, I apologize. Okay, so I made a little change to this, and I added that our assignments will be here. And what we'll do is, I'm going to try, I'm not going to promise because I always break my promises, but I'm going to try tomorrow to go on ahead and do the assignments and give them to you so you'll be ready. Obviously not number 4, but number 1, 2, and 3. I think I have number 3 I have in my head. I think I know what I want to do there. It's a fun problem. It's not it's a variation on a classic problem. It should be okay. Number 2, I got an idea of what I want to do with that one as well. Number 1 is the one where I'm sort of struggling. How many of you feel like a math problem would be interesting? Anybody? Okay, so that's a diagonal. I like that. So, John, you don't want a math problem? No. How about a fun math problem? How about a math problem where you have to make calculations? Yeah? Okay. I think I see where this is going.
Like if you're rising type
No,
now?
probably. I'm thinking what I'll do is probably give an assignment on the Stapest algorithm, which is the sampling. It's the Gaber Stapest algorithm. It's a sampling algorithm to invert Laplace transforms. I've got a version of it somewhere in Excel. And Excel, of course, isn't very accurate, and this thing likes to have accurate numbers. So if you wanted to do it in MATLAB or Mathematica would probably be better, but I could give you the Excel. And there's an old problem that I used to give where you would test it against various things, sort of your own kind of test and see how well it worked. There have been people in this class that misunderstood what programming is, and they would take an algorithm and they would build it in columns in Excel. That's not what I would suggest with this one. I would suggest you put it in Visual Basic and then you call it, like a function or something like that. And if you have no idea what I'm talking about, then use the product that you're comfortable with. But you talk about difficult to debug when you start making calculations. And, the cells, because the calculation is huge, because it's an iteration or whatever, there's like, you make a mistake and it translates all the way over there. No, don't do that. So, I did put in a couple more quotes today. I thought this was my own quote here. Never own anything that eats while you sleep. Did you grow up on a farm, Santiago? No, because you were in Buenos Aires. What about you, John? Farm? No? No farms in Korea. Only golf courses, right? Did you grow up on a farm? No. Farm? No. Farm? No. Do you like McDonald's?
Not too much.
Yeah, good for you. Farm? Farm? Nobody grew up on a farm? Okay. Why don't you want to own anything that eats while you sleep? It's money going out of your pocket. Yeah. And then never own anything that needs to be repainted. If you have to ask what that means, you'll know. And then I was looking around today and I found a quote that was similar to this, but it was never own anything you can't drive a nail in. What does that mean, Avery? Would you drive a nail in your nice paneled walls in your study? Then that's too nice. See what I mean? Their quote was never own anything you couldn't drill a hole in, but that didn't really translate very well for what I wanted to use. I always believe that you should work harder than the people you work for, so, that's sort of my philosophy. And a number of years ago, I was at a conference where somebody was, dealing with faculty is so hard, it's like trying to herd cats. Have you ever heard about herding cats? You don't get that? Is it too much English? Like getting cats to go in the direction you want? Okay. So I thought about it for a minute, and I thought it's easy to herd cats. Be a rat, so there you have it. Never say no, and there's no limit to where you can go. I like that. That's my quote. So, this is my bio, for those of you who care. And in terms of guidance, this is graduate school. How many A's should there be in this class?
5%.
Okay.
I'd say everyone is there at once.
Okay, that's the right answer. But this is what I'm asking for. This is graduate school. The person you're competing against is in the mirror. It's probably the first time in your career you've had this kind of opportunity. Next is I only want you to give me your best work. If it's not your best, don't give it to me. Because once you transfer ownership, it's mine. And after that, I'm going to do things to it. Good work is easy to grade. Hard work is hard to grade, or bad work is hard to grade, and then I get upset. And you don't want me upset. There's only one thing I really hate about being a faculty member, and that's grading. Because it's like being a dentist. I gotta find something wrong. When you go to the dentist, that's their job. They gotta find something wrong. So that's me. Focus. This is an essential course in reservoir engineering. Everything we do in this course will be used throughout your reservoir engineering career. Okay? You're not going to appreciate it right now, but that's okay. Timeliness. This is very dense material. He said this is the first 7 chapters.
Yeah.
Well, by the time, it'll be this tall. Do I expect you to know every word? Of course not. But do I expect you to at least go through this? Yeah. I did. Remember this quote over here? Always work harder than those you work for. You work for me, so you're supposed to work harder than me. Be prepared. The material, it will teach itself. A lot of people get frustrated by that. They say, well, you've already worked out all the details for us. Yeah and no, because I can always give you a problem that is a change of one of those. So, give me your best effort. I'm here to help. I'll answer your questions. I'll do it within 24 hours if at all possible. That's as close as I can get to a promise. Unless I'm on an airplane or something else is wrong, I don't let messages sit in my inbox. Okay? But, if you ask me something stupid, or you ask me something you already know the answer to, I might not be so happy. Today, somebody sent me an email and they said, is this what you mean, or is this what you want? I don't know. You tell me. If it's on paper, or if it's in, if it's in an email, or if it's in a memo, or if it's in an assignment, that's what I want. So, questions are fine, but I try to be self-explanatory. And by the way, I do make mistakes. I make typos. I'm human. I wear glasses to read now. It's terrible. And, that's life. We get old. We get tired. We get fat. We get bald. We get daughters and sons and wives and things like that. And sometimes you're not thinking. And sometimes your brain, whenever I program, I always make a lot of mistakes. So, I expect that you're going to find a few of my mistakes from time to time. That's okay. Questions before we leave this? Is everybody reasonably happy? So not an overly large amount of work, right? 4 problems. Is it a trick? Avery thinks it is.
I don't think it's a trick, but I've taken some very long exams over just a couple problems.
Okay. You think you should wait till the night before to do these? No.
Start looking at them and just
at least read it. Pencil in one hand, highlighter in the other. Point out where I made a mistake, that kind of thing. Okay. You okay with that? Yeah. I got to figure out a new name for you. Can we make something out of Dreyfus?
Yeah, we can.
What can we make?
You tell me.
I don't know. I've got nothing.
You seem to have the imagination, I don't.
You want me to call you King Louis?
Maybe wait for the first assignment.
Okay. No, you're all going to do well. What kind of bad dreams do you have?
Bad dreams?
Yeah.
In my life?
Yeah. Do you dream of being tortured? Do you dream of being pushed out of an airplane? Do you dream of, waking up as a dog or, something like that?
I've seen dreams, but that's not the place to...
It's not the place to explain? Okay, so what I want you to think about is, when you're having one of these bad dreams, I'm going to be in it. Okay? And unfortunately, it's probably going to happen when you're back in France. And the course will be over. Okay? But I promise I won't hurt you much.
I'll send you an email.
Yeah, I'm sure you will. Actually, because my mobile is all over the place, you'll probably call me. But what you don't know is I might not pick up. So, 4 problems. The 4th problem will probably be 30 points, and the other 3 will probably be 20 points. I thought about making them 15 points and making the 4th problem 45 points, but that's probably too much credit, so we'll see. But that individual project, there are no preconceived bounds in my mind. We'll sit down, we'll talk, we'll work on it together, we'll decide this is what I want to do, and I'll give you some guidelines on how I want you to write it up, and then you'll give me that, and I'll be happy. But, it can be something original, it can be something related to your research, but the whole purpose of this is for you to synthesize a problem from the start to the finish, explain it, and basically be proud of it. So we'll close that file. We'll come back over to this one. Did I show you this trick yet? So you can write on here. Neat, huh?
That's the whole reason we switched classrooms, isn't it?
Sorry?
That's why we switched classrooms, right?
You were out of the room, but yes, in one way, that was why I wanted to get out of there, because I hate that there's 3 monitors, and I constantly lose the mouse, and sometimes I lose my temper and say bad words on the recording. Okay, so the first 2 books are Advanced Math for Engineers and Scientists, and I know you're all going to find the 2nd edition, but you need the 1st edition. Why? Because the notes refer to the 1st edition. There's some problems in the notes that you can work for self-study, and they're in the 1st edition. If you buy the 2nd edition, it's not going to make any sense because they changed the book. Okay. Conduction of heat and solids. Carcel and Yeager, where were they? Where did they work? Good guess. Wrong. Wrong.
Shed?
Wrong. Wrong. Sorry? He's looking it up. They worked in Tasmania. Yeah. Okay. And they basically documented every sort of normal kind of problem that you could imagine with heat conduction. Who's a mechanical engineer? Okay, so, you know, you come over here and you touch the window, and the window feels hot, the wall feels cold, and you understand that Fourier's law describes, well, not perfectly, but it describes the heat flux behavior because of the material. They solved radial problems, spherical problems, linear problems. They solved strip problems. They solved problems for mines. They solved problems for, just about anything you could imagine. And if they'd have kept going, they probably would have solved every problem we ever needed. Did they solve the fractured well problem? Yep. They didn't call it the fractured well problem. They called it the strip inside of a strip problem. And believe it or not, some 20 years later, the petroleum engineering guys come along and they derive a similar solution. I'm surprised they never caught it because it's in one of Carcel and Yeager's papers. I don't recall exactly if it's in their textbook, but it's in their papers. Okay. And then the rest I give you electronically. So, here, 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 here. They're all available electronically. Now, we don't have any Russians this time. So I have to ask, this handbook for computing elementary functions, this guy is Russian. Okay. This approximation for digital computers, look when it was written, 1955, 1965. What are these books for? Let's pretend that we're 1955 and you want to make a calculation using a computer. How are you going to do it? What operations can computers perform? Addition, subtraction, multiplication, division, and logic. There's no exponential button, there's no logarithm button, there's none of that. You have only 4 functions. So what Hastings et al. Did is they created min-max polynomial expressions for these functions. They did this the hard way. They figured out a way to use simple arithmetic calculations to create relationships that you can push a button on your calculator and get a number. We owe them an incredible debt for taking on this challenge. There may have been other books at the time, but this is the one that I found and that I like the best. It's good. I have a very, nostalgic or sentimental streak. I like that. The Russian book was, I think it may have been published before 1965, but it was republished in English. The Americans solved their problems using approximation by polynomials. How did the Russians solve their problems? The American book is about like that. The Russian book is about like that. How did they do it? They used Taylor series expansions. They used the analytical solution for a given function, split it out into parts, took pieces of it. They were much more elegant in their approach. Who won? Hastings. Or that approach. You cannot use Taylor series expansions to achieve the necessary accuracy to make these calculations. You have to use something else. Okay. So whenever you push exponential on your calculator or on your computer, it's going back and it's looking at some kind of a calculation like Hastings would have derived. Now, I don't know exactly what Mathematica does. I know they go back to the purest form of something and compute from that. But I also know that Mathematica has some flaws in some of its calculations, but I would suspect it does not rely on these the approximations by Hastings or the approximations by the Russian guys, the expansions. I think they rely on internal calculations of those functions. Mathematica is probably the better product to use in all this because it's going to take the calculation as best it can to whatever precision you specify. Okay. Then we have a numerical methods book by Hornbeck. We have tables of Laplace transforms as we talked about on Tuesday, and we have handbook of mathematical functions. I've also thrown in a couple of other things in the reference. There's a book by Camacho, who's a friend of yours. There's a book by Ozkin, who's both of these guys went to Tulsa, and their advisor was a fellow by the name of Raghavan, who was an artist / mathematician, so his student work is in there. There's some other books. There's a book by Muscat, which is a classic book in petroleum engineering. Muscat wrote that book, I believe, in 1938 or 1939. Had Muscat had a computer, we would have been out of business because he would have solved every problem that has been of any value to us. So just FYI, there's plenty of good things to read in that reference section. So I think you'll be happy with that. So all the ones in red are given to you. The ones in green you'll need to buy if you want them. I would strongly encourage you to buy them. I'm not saying that you're going to use them every day, but in fact, I'm not sure you're going to use them much at all. But the book by Shams, you can use that to guide yourself through the math review, and the book by Carcel and Yeager is just something that you'll be surprised. It's kind of a nice book that every time you open it, there's something new in it. All right. Now, all of these optional resources, I guess I can't do that. All of these I must have touched this thing wrong. How do I clear it? See the button?
You have to go back up. Is there an option in that smart link?
Oh, I bet you're right. I bet I have to turn it back on. Okay, thank you.
Yeah, it's up to you.
Oh, great. Now I gotta use the eraser.
It's right behind you.
Obviously, I've never used this before, so foolish me. All right, all of these are just going to be painful. You're going to have to buy them. This is a, okay, this is a calculus book along the same lines, lots of problems, differential equations, Laplace transforms, numerical analysis. These books are probably $10 or $12 a piece. They might be a little bit more expensive than that now. The mathematics of diffusion is kind of like Hartzell-Jaeger, crank, worked out a bunch of stuff that we use. This table of integrals and products, I confess I even used it the other day. That is an awful book. It's about like that. Methods of Numerical Integration by Rabinowitz and Davis, that's a good book. And this atlas of functions, you probably don't want this one, but it's the secondary version of Abramowitz and Stegan, so it's sort of an update of that. But Abramowitz and Stegan is better, actually, so I probably wouldn't worry about that. Bender and Orszag is an excellent book. This asymptotic expansions, I've used that. These are all things that I've used in my work historically. The atlas of functions I probably wouldn't bother with, but the rest are interesting. Now, that's, let's say 15, 60, probably 20, so we're up to 80, probably $50, so that's $130, probably another $50, so that's, we're talking about $300 or $400 worth of books here, so I don't expect you to buy them. I'm just giving you guidance on things that you could use if you wanted to. Okay, everybody happy with that? You're not required to buy the book. I'll repeat that again. You're not required to buy the optional books. Okay. So, like I said, I kept a little back, and I will, of course, everything on the course website will be here. It'll also be on e-learning for the videos. The basis for grades is here, and I'll make it, this class participation is basically just something that I keep behind. So in case you decide you want to not do your work on time or that sort of thing, then I keep that back. I basically never penalize anybody unless they force me to. All this other stuff on grading and procedures is boilerplate. I'm not suggesting it's not important, but I don't want to talk about it because you're all adults, and I've already told you the only person you're competing against is yourself. Okay. These are the topics that we'll cover. We have a mathematics review. I'm really not thrilled with the mathematics review, but I suspect getting a feeling from this group, you would like that, but we'll, in the past I have ignored it, but I think we'll cover it this time, and we'll go through the mathematics review and be happy about it. Touch physical properties is the next part. So tell me, Goo-Goo, where you at? This is Goo-Goo here. Yes. Yeah, that's Goo-Goo. I forgot what I was going to say. What's your hobby?
Hobby.
No, the other Goo-Goo. We don't have a nickname for you yet. Speaking English? Hobby. Hobby. What do you enjoy doing? Not work.
Hobby.
Forget this.
Hobby, rugby, reading.
Rugby? Rugby's for girls. All right, reading? Reading and rugby.
Yeah.
That's a very strange combination. Anything else?
Yeah, many.
That's all we're getting. We have to pay for answers from now on? Okay. So, are you any good at rugby?
Yeah.
Yeah? A little guy like you, though, they're going to rip you apart if they ever catch you. You're not worried about that? If they catch you, they'll tear you to pieces.
Maybe, yeah.
Oh, you're saying they've never caught you?
No, in fact, they are not running after me, it's me running after them.
Oh, you're another kind of player, I see. Okay. So, you don't have any kind of other hobbies where, like art or poetry or
I like
making...
poetry, but It's always strange to say one of your hobbies is poetry.
Why? We have to admit what we like. Otherwise, we don't know how to treat each other, you know? Okay, so this is kind of like my poetry. I'm not very good at it, but I like it. And I think of myself as sort of a petrophysicist from time to time. And you look at some of the work I've done, I've tried to create fundamental models, I've tried to understand the fundamentals of petrophysics, and so forth. But it's not really my destiny, I guess. Like it's not my destiny to be a poet. It's not my destiny to be a petrophysicist. What I'm really fascinated by is how these things connect and how they don't connect. And it gets worse the lower the permeability we have, the worse, the more impermeable something is. And actually, things get kind of strange the higher the permeability you get as well. Things like fractured reservoirs, dual porosity systems, etc. So I hope you'll enjoy this part of the course. I mean, you'll see the sparkle in my eye that I really like talking about petrophysics. This correlation part is usually what I give homeworks on, but I probably won't do that this time. I'll probably give you a homework on this. I love going through and deriving Darcy's law. I love capillary pressure, relative permeability, because these are all connected. You know, each one of them is connected with the other. Electrical properties is interesting. I don't pretend to know enough about electricity to say. So, you know, at any rate, if we were talking about poetry, this would be my poetry. Okay. All right. So next, we have to cover some sort of boring stuff. Why is it boring? John? What makes it boring? That word. So you were in the Army? You were in the Army? Can't say. Is anybody else in the Army? Does France have an Army? Okay. So what did you like about the Army? The day you got out?
Waking up early
Waking up early. Oh.
and doing nothing.
Exercises. Then you're going to love this, because that's exactly what we're going to do. We're going to wake up early and we're going to do exercises. You're going to say, Tom, this is stupid. Steady state doesn't exist. Why are we deriving all these steady state relationships? Then you're going to say, the non-laminar flow relationship isn't important. Why are we deriving that? And then you're going to say, material balance, that's great on paper, but it doesn't work in practice. Is that true? How many chemical engineers? No? How many pretend to be chemical engineers? How many wish they were chemical engineers? How many hate chemical engineers? Wow, we have two honest people. Okay. So, material balance is a mass accounting of the system. Is it correct? Yes, no, or maybe? Yes, it is correct. It's exact. For the problem you described, material balance is exact. And then what do we do? Smurf? We put information into it that's not exact. What happens whenever you put, whenever you have a model that is a rigorous analytics model, and you put the wrong data into it, does it crash? No. It just gives you the wrong answer. That's the whole purpose of analytics. Okay. Do you know it's the wrong answer? That's the problem. That's exactly what the problem is. And by definition, what do we sell in this industry? We sell volumes of oil and gas. Do we sell volumes of water? No. They are a penalty. They are something that is a cost to us. There may be one or two places in the world where people take oil field water and sell it. I can't think of anywhere that would occur, but maybe there are one or two places in the world. Everywhere else, we have to pay someone to take it off our hands. How much do you pay in Argentina per barrel? Per barrel.
Oil,
Water.
we injected most of the water.
But what's your cost per barrel?
Cost per barrel is between $25 to $30 per barrel in the basin that I've been working
For oil.
for oil.
What about for water?
Well, most of the cost of production is between $25 and $30, and most of it is in the energy that you spend.
You spend $25 or $30 per barrel,
Yes.
but you only get $40 per barrel.
Now we are.
Oh, you get market price now?
No, not market, but between 55 and 60.
Okay. Argentina has a special system. You don't get market price.
Most
You
of-
do get market price on some things,
Yeah,
but not.
most of the cost of these $25.
But that's everything. That's not just water.
No, it's everything, but
Yeah.
water would be 60 to 70%.
Really?
For the
That
water.
expensive? Wow.
Yeah. Well,
Yeah, usually you hope it's maybe 50 cents a barrel or $1 a barrel, maybe $5 a barrel if you have to truck it, but that's a lot of money. At any rate, we produce a lot of water in oil and gas. Do we sell that water? No. We pay somebody to take it away. Do we usually measure the water volume? 3 options. Yes, no, maybe.
I mean, the only reason you measure it is as you're trying to get rid of it.
Right, you're going to have to pay somebody to take it away.
So you'd have to measure.
But if you're not paying somebody to take it away, how accurate do you think those measurements are? I'm just throwing this out. The measurements of oil and gas are going to be as accurate as your accounting system will tolerate because you're selling those. Water's not going to be a priority. Okay? Is water part of the mass of the system? Yeah. So there's an error. But what's going to be a bigger error? Jorge, how do you measure pressure in wells in Mexico?
Wow, difficult to answer that question.
Okay, we have a politician. Let's go back to the Argentina engineer. How do you measure pressure?
Wellhead?
Okay, you measure it at the wellhead. On every well?
No,
Every day?
no.
Is it accurate? Let's make a song. No, 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 no,
We
no.
measure a station,
Okay,
not every well.
okay,
We might measure at a specific well for a specific reason.
okay.
For a bit of
But
time.
material balance requires that you have accurate volumes, and again, let's repeat ourselves. What's the measure of energy in petroleum engineering? It's pressure. So if you don't have the right volumes and you don't have the right pressures, where's this going to go?
You have the right mass balance.
You're done.
But you already have uncertainty in the values of volume, right?
Of the
Of the values of the reserves of the volume? You have-
Sure, but where I'm going with this is that, we do have commercial software that does material balance, and the equations are exact, but the information going into it isn't,
Right.
and you have to recognize that. Material balance was first begun in the early 1930s, okay? People were using it then. And then, what happened was, we said, this isn't working. So, we cannot use the information and obtain estimates. So what do we do instead? We use the information and we make projections. This is where reservoir simulation came from. All right? So then you apply your uncertainties to that and you make your conjecture that I believe this is a relevant model because of this level of uncertainty. So you're going to hear me talk a lot about reservoir simulation. Reservoir simulation is not my poetry. Reservoir simulation is my devil, okay? Because all you do is put your data in the simulator and say, oh, please, Mr. Simulator, who we worship, give us an answer that we can live with. No, I'm terrible. It's not that bad, but you have to be very careful with simulations. Do you think that maybe you would like to be a simulation engineer?
Yes.
Why? Tell the truth, because nobody can tell you're wrong.
We can get the answer by numbers.
Okay? But who checks your answers? Yeah, there's the problem, okay? No, I'm picking on you, but the problem with reservoir simulation is you have to have a basis. You have to have some ground truthing, and you have to validate. There's a whole army of people who do reservoir simulation, and they make a ton of money. And most of them are very careful. But do you have to be careful? Well, I mean, the software doesn't care if you're careful or not. What happens if somebody gives you the wrong geologic model and you put it in? That happens every day.
You'll get an answer.
Exactly. And then you're wondering why you're producing water over there, oil over there, and something else somewhere else when the model says that none of that should be happening. I'm just trying to give you an example of why we're going through all of this. The foundations are important. Does a simulator have to be material balance correct? Of course. If a simulator leaks, that's a dead giveaway, it's wrong. So when you're taking Dr. Maridi's class, you're constantly checking, and it should be something like 10 to the minus 14th error in volume. It accounts for all the volume. If it starts to drift away, then you know you've got a problem with your model. That's how people check it. All right, pseudo-steady state is not steady state, but it's time-dependent sort of steady state. So what happens is that steady state means what? Things don't change. Pseudo-steady state means things change, but they change in a sort of steady fashion. The definition of pseudo-steady state is that the pressure at all points in the reservoir changes at the same rate. Okay? So let's do that. Ready? Everybody stand up. We need a little exercise. Ready? Hand up. Okay? We're going to do the chicken dance. All right? We're going to all go down at the same rate. Okay? We got to be steady state. Ready? 1, 2, 3. All going to go down at the same rate. That's pretty good. But is that really how things work in a reservoir? What happens is I start going down at the well, then you, and then you. See how that works? But then when we get to steady state, or we don't have steady state, we have pseudo-steady state, the pressure at all points in the reservoir goes down at the same rate. You can sit down. If that isn't happening, then that's not pseudo-steady state. If it's not pseudo-steady state, then all the assumptions we put into this aren't correct. If it's not pseudo-steady state, then what is it? Okay. That's our vernacular. And whenever something is time-dependent, we call it transient. Whenever all of the system is not in equilibrium, declining at the same rate, we call it transient. Unfortunately, transient is where? Transient's down here. We talk about pseudo-steady state first. Why? Because we can derive that directly. You remember that differential equation we talked about, the diffusivity equation? Maybe we didn't talk about it yet. But what happens is for pseudo-steady state, we assume that the right-hand side of that equation is constant. So we have a second-order linear differential equation. We can integrate it twice, and that gives us a response function. Okay? But if the right-hand side of that equation were not constant, if that condition were not met, then that wouldn't be true. And then we derive the diffusion equation. Okay? I didn't say derivation, I said development, so it wouldn't make you mad. But how do we start? What are the 5 equations we need? Count them out. Number 1, continuity. Number 2, okay, equation of motion. Number 3, equation of state. Number 4, it is thermal equation. Number 5, We need a constitutive equation. That equation describes the behavior of the fluid, shear rate, shear stress. If it's a Newtonian fluid, then it goes in the equation of motion. If there are no thermal effects, we ignore that. We must have an equation of state, an equation of motion, an equation of continuity. We take all those three, we marry them together, and we have a diffusivity equation. So we have a diffusivity equation for liquid, we have a diffusivity equation for gas, and then we have the multi-phase diffusivity relationships. When's the last time you had a light bulb go off over your head? You know, a light bulb, like in the cartoons, when you learn something and the light bulb goes on, you know?
It was the night before a test. I was sitting down in the basement of Blasingame studying for differential equations, and all of a sudden,
Okay? When was the last time you had a light bulb go on over your head?
Yeah, yeah.
Really?
Yeah.
Wow. Santiago?
I don't remember.
You're supposed to say it was when my wife said she would marry me, or something like that. When's the last time you had a light bulb go off over your head?
7 months ago.
7 months?
In Hawaii. My honeymoon.
Oh. Okay, this is family hour. No more. We don't want to know. You don't want to say, do you? When's the last time you had a light bulb on top of your head? Like you realized something. What? Oh, I get it. Yesterday. Yesterday?
No, 4 months ago.
4 months ago.
Yeah, during my internship
Oh, really? Where was that?
at
At Schlumberger. You realized that you were a slave? Did they send you to Fort Harcourt? Did they send you to Nigeria?
No.
Yeah, they will. Okay. Yeah, okay. And then next stop, Russia. Next stop, yeah.
Comodoro.
Sorry?
Comodoro.
Yeah, Comodoro. Or maybe, was it Rio Grande?
Yeah.
The one that's further down? Yeah. When's the last time you had a light bulb go?
I think today.
Really?
Because I read that the oil is biodegradable. I didn't know that.
You didn't know that?
No.
We're all organic.
Yeah, but
It's dinosaur blood.
I thought petroleum was like the end of the process and not the.
No. This was Dr. Harris' class?
No, in the library.
Oh, okay. So, you know, they estimate that 95 to 98% of the hydrocarbons that were generated leaked out. They just went away. Where'd they go? Something ate them, because something eats everything, right? Everything we have is organic. So there's little bugs that like to eat oil and gas. There's little bugs that like to eat wood and that sort of thing. It's all a process. Good. I don't know if I want to ask. When's the light bulb?
I think it's just now I looked at the time and I realized that we wouldn't start the course today either.
We are starting. You know, I told you, education is the only investment where the customer doesn't want their money's worth. I give you more than you could possibly consume. So that's your answer. Great. Jorge?
When I realized to get a master,
Okay.
get out Phoenix, get away from.
Smurf? You don't like Smurf, do you? We're not going to paint you blue. You remember Smurfs are blue?
Yeah. I guess a week back, when I decided to ask my major to keep focusing on what they're researching.
What are you going to focus on?
Basically on reservoirs, I'm working on shale gas.
Okay. John? You don't remember? So what happened in here is I had, at one point in this class, some older students, not like your age, but like my age, okay? And we're deriving the diffusivity equation. And I'm not exaggerating. The student starts doing this. And then he goes, I get it. I said, what do you get, Joe? And he said, those are the same equations that you have in a reservoir simulation program. And I said, yes, it's all the same. And he goes, we never derived them before, they just gave them to us. I said, yes, that's why we derived them, so you'll know their assumptions. I got it. Sometimes it happens.
So that's the danger. You start getting people using programs that they don't understand the limitations. Because I saw that with some of the stuff I was doing in industry, not petroleum, but just.
It happens in every discipline. And the more complicated the software is, the less complicated the user is. You know, it happens every day. And what's happening right now in things like shales is people are taking shortcuts. There's no way that we can truly describe what's going on. So, you come up with your model, 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 and so on. And then you all write a software program for that, and I'm the consumer. Your model isn't anything like hers, but the answers are sort of similar. And you're telling me, well, it all looks like this. But you're not modeling the physics correctly, and she's not modeling the geometry correctly, and I'm like this. And then he comes along and he says, well, I fixed the geometry part. And he comes along and says, I fixed the physics part, but I had to make an approximation for something else. And then he comes along and he writes a solution for the whole thing. And how long does it take to run? Like 3,000 times longer than yours. So who's going to wait for that? Because the whole purpose is to get an estimate of parameters, move forward, and so on. This is what happens in software. And then next we go into the classical solutions. We talk about, why do we make things dimensionless? Nobody has a mathematics degree here, do you? Mathematics degree? Everybody's an engineer. Okay. So what's the problem with people in math and physics when they come take engineering? They look at all the extra variables and they're like, why did you do this? It should just be y equals something times x. Yes, well that's what we do with dimensionless variables. We simplify the form of the problem into a mathematically convenient form. We also have to make the boundary conditions, the initial conditions, and so forth dimensionless as well. We focus on the radial flow case because it's the easiest one, it's the most prevalent one, but we also do linear flow, we do fractured wells, and so forth. I'll go through this a bit quickly since the customer wants to hurry up. Is that right, Gugu? So we have dimensionless variables, solutions of the radial flow diffusivity equation, Laplace transform, real domain, these are all connected, okay? Then we have linear flow. Why should we study linear flow? Linear flow means that the reservoir looks like this, and there's flow going through it in this fashion. The coordinate system could just look like that. Do we have reservoirs that look like that in the world? Okay, hadn't thought about that, thank you. I was thinking of reservoirs, not fractures, but you want to take another guess? So when you go back to IFP, my French friends, they're going to make you take a whole bunch of geology classes, and they're going to show you geologic systems that do this. Where you have very complicated river systems depositing on top of each other. If I'm looking at only this piece, and I ignore the rest of it, and I put a well right there, what's the dominant regime? It'll be linear, perhaps. Perhaps. Do we have a lot of these kind of cases? No. A few. Now, we may have 50 of these layered on top of each other, and the well penetrates a whole bunch of them. Then what is the regime? I'm going to introduce you to something, okay? It's called the GOK theorem. Do you know the GOK theorem, Santiago? God only knows. So how do we get around that? We make some simplifying assumptions. But on the other hand, linear flow could be a very powerful solution for us because it enables the fractured well. We need the linear flow concept because what happens with a fractured well is we have starting to make me sick. Okay, so we put a fractured well here. What's the flux going to do to the fractured well? Will there be flux in the fracture? Yes, no, or maybe? Which one?
Can you further define flux?
Hmm?
Will you further define flux?
Okay, let's ask Maddie and Gugu since they were talking. Oh, sorry. You're...
Pam.
Yeah, he's Pamp. Okay. My apologies. So Pamp and Gugu were talking. Which is it? Yes, no, or maybe?
That's block. What you said. Block in the fracture.
So this is what the fracture looks like. It's exaggerated. This is the width. The width of the fracture and the fracture half length. Like that. Okay. This is the usual terms we use. What's the fracture filled with?
I don't know. This is the well.
The well is here. We projected. Here's the well. Here's the formation. Okay? And we have hydraulically fractured this well. So we have, well, I didn't draw it very well. Pardon me. We have a fracture that propagates out to this far and that far. Like that. So we create a hydraulic fracture. How do we create it?
High pressure water.
Water. Hydraulic. Okay, so we pump water in. Why does it fracture in one direction? You guys like One Direction? Harry, Liam, Niall? Are we going to have a Halloween party where you dress up as One Direction?
I hope.
Yeah, we should do that.
Is that a French man?
You look kind of like Niall. When you have a 13-year-old daughter, One Direction's on your mind. All right. So we're going to create a hydraulic fracture. What's going to happen in that fracture, Santiago? We create it, and when we stop pumping, what happens?
Well, we found the propan will close.
What happens if we don't pump proppant?
It's closed.
Does it close exactly? There's some people say that there's a shear effect, that it shifts slightly. Do you believe that? Or is that just something people make up to explain things they don't understand?
I don't know.
Yeah.
I think it's closed.
Okay. You think it closes?
Yes.
So we put proppant in it,
Yes.
and the proppant holds it open. You want to tell these guys where all the proppant goes?
Well, the
I drew an idealized fracture. The fracture really looks like this.
Yes, the software show like that, but
It looks like this.
yeah.
Where's the proppant go? And maybe some of it up here?
Yes. If it is well fractured,
You
it
know,
should go.
or if we
down.
had good transport?
Yes, and
How do you transport the sand?
with a gel,
Mechanical engineers?
with a viscous.
You're going to have some sort of a viscous fluid. Do you want that viscous fluid to stay viscous?
No,
No.
I don't want you.
You want it to dissolve or to break. Okay? So we approximate fractures in reservoir engineering as a plane. So this is a perfect plane. And you could even go as far as to say we make it a rectangle. So this is the side view, and this is the top view. So somehow we filled it all with sand. Okay? Is there a pressure drop in the fracture? 3 options. Yes, no, or maybe. We have yes. How many votes for yes? Everybody. You didn't vote. Okay, so it's big N minus 1 and 0 and 1. Is that right? How many people? 2, 4, 6, 8, 13, I guess. So 12 and 1. So is there pressure drop in the fracture? Everybody says yes.
But if you want the fluid to flow out of the reservoir into the fracture and then into the well, I would say it's better if there is a pressure drop.
If there is a pressure drop, wouldn't you rather there be no pressure drop?
Well,
That a particle of fluid would enter here and it would magically be transported to the wellbore with delta P equal to 0?
no,
That's an energy loss.
no. If you want it to go from the reservoir into the fracture, it has to lose energy.
No, that's getting into the fracture. I'm talking about in the fracture itself. Don't you want the fracture to be a magic place where a particle of fluid enters and magically goes to the wellbore?
Yeah.
Okay? That's called an infinite conductivity fracture. So there's nothing in the way. Can we pump an infinite conductivity fracture, Santiago? Why?
I think this is assumed as a case, I know.
Right. But why can't we pump an infinite conductivity fracture?
Because the propan package has some permeability.
Right, but if we pump only big pieces, that would be very high conductivity. But then the big pieces aren't going to go very far, are they? Because they're going to drop out. So we balance it out. We pump successfully larger pieces so we get some sort of a distribution. I'm trying to make a point. You said we weren't learning anything yet, but we're learning a lot. We're learning that a fractured well usually if we're designing it right, it does not have a pressure drop in the fracture, but we know it does. Our goal is to obtain a maximum permeability in the fracture at a minimum cost. That's the thing we're really talking about. Dr. Valco is going to go into a lot more detail than this. He's going to describe how you balance the proppant with the energy that you have to use to create the fracture and so on. A lot of this is theoretical, but from the standpoint of us as engineers, can the fracture have a permeability of infinity? For all intents and purposes, if the permeability of this is 20,000 times greater than that, then that's pretty unlikely that you're going to have a problem. On the other hand, we like to think of fractures, or we like to think in mathematical terms of things being uniform. And so there's a possibility that the flux at all points entering the fracture, the flux here, the flux coming in here, is uniform across the fracture. Is that going to happen?
The beginning.
Oops. That's cool. Is that going to happen? Mathematically, that's how we set up the problem. But the reality is, that's not how it happens. We've got two choices. Either the permeability is infinite, or it's not infinite. It's probably not going to match our mathematical assumption that if I walk down the fracture with a device, everywhere I check, the flux coming in is the same. Mathematically, we can do that. But practically, we can't. Okay? So, how do we model a fracture well? In the simplest form. Why don't we take two pieces of rock that look like this. Sorry, my artistry is not very good tonight. And so we have two pieces of rock, and we have flux coming in from this way, and we have flux coming in from that way. And the fracture is actually the distance in between. But that only represents flux in the linear direction. Is flux in the linear direction going to be forever?
Elliptical after a while.
Okay, but what Santiago is saying is I've used two pieces of rock facing each other to simulate a fracture. And we have two solutions, we just add them together. Okay. Right. But the reality is we have to model this differently. Because we can model this as two pieces of rock when we're seeing flux like that. But sooner or later, you said what's going to happen?
Elliptical.
Why? Because of the tip. Eventually you'll have flux around the tip. Like this. And then it'll become elliptical. What's another name for elliptical? Pseudo-radial. So we have to be able to derive a solution that represents all of this. Now, it turns out that this linear flow solution is a decent approximation, and it gives us insight into other parts of it. But the reality is that the way we're going to model this is we're going to take this solution for the radial flow case, let's do this one, and we're going to take a line, which is what that is, and we're going to integrate that line across XF and XF. So we're going to start integrating here, and we'll go all the way across, and that will create a plane. Okay? That's how we're going to derive it in this class. So that'll be our solution for a fractured well. That'll be sometime in November. But that's the simple case of uniform flux, because we use the uniform flux vertical well to derive it. The flux into that well at all points is uniform. So when we integrate across it, it's uniform. Okay? Jorge, you remember Dr. Samaniego from your days at UNAM? What did he do? He and Dr. Cinco Ley, they took this concept and they said, we have to treat this as a reservoir, and we have to treat the outer part as a reservoir, and they're connected at the edge of the fracture. And so you have to account for the flux distribution in the fracture. And that became what? The finite conductivity solution. It is very painful because it's half analytical and half numerical. Why? Santiago, do you know? Because if the permeability inside the fracture is low, then the flux varies along the fracture. So you have to compute. You have to break it up into blocks. And you have to compute the flux coming that way across those blocks. So that part has to be numerical. Can you solve this equation exactly? I know we're way off tune right now. But can this particular problem be solved exactly? The answer is yes. There's a couple of ways. One is to go to elliptical flow and represent the fracture as an ellipse, and you can do it that way. Another is to use sort of a mean value theorem to represent the flux in the fracture. Schlumberger patented that solution. That's why you won't find it in any publications. They patented that solution. So that's a direct solution to this problem. Okay. All right? And then the rest, in terms of the context, is variation on changing the behavior in the reservoir. So now we have two systems. We have a fracture system and a matrix system. Or maybe we have some other kind of nonlinear condition, or maybe we have some time-dependent pressure or some time-dependent rate. That's what these derivations are over here. So this is changes in the reservoir. This is changes in having a nonlinearity in the system. And this is changes in the rate or pressure in the system. Again, all of these things have a direct application into mainstream reservoir engineering.
Professor,
Mm-hmm.
could you give us an idea of the dimension?
Oh yeah, sure. At the wellbore, it's probably on the order of 1 to 2 centimeters. And out here, approximately 100 meters. It's of course 0. So, that's where the tip will be.
And so, how do you stop it? You start to drill them?
The first thing you do is you complete the well, you cement the pipe in place, and then you come back with a device that has charges on it, and those charges puncture the casing and the cement. There's a lot of design around this, and the people that are petroleum engineers know this, but they use the same technology that you use in the military for burning through tanks. So it's the same principle. Is there's a propellant and there's a liquid metal that burns through the steel, burns through the cement, burns through the formation. It could go almost 1.5 meters. Almost. Usually they're designed for less than that. They will usually use 6 to 12 shots per foot. Sorry, we're going to talk in English units. So there'll be phased in a radial pattern, and there'll be 6 to 12 shots per foot, like that. Okay, so now you have holes. Now you inject fluid. Generally you start with a light fluid of water that's treated with chemicals, and then as you progress, you add more and more gel to the fluid, and it breaks the rock. And the rock will fracture vertically at depth, and it will fracture generally in one plane. There may be stress heterogeneity or stress anisotropy in the system, and it may wiggle around. But generally speaking, we think it breaks in one plane. I can demonstrate this, but if you hold your hands together and stand on them, you can open them. And fractures propagate perpendicular to the least principal stress, so it'll open that way. And generally speaking, it'll only go in one direction. Now, there are studies that show that near the well there's a star-shaped fracture. There's one main fracture and a couple of little ones, but they're not very big at all. There may be 100 or 200 centimeters, or sorry, not centimeters, millimeters. They're not very big. They're like a borehole breakout. The main fracture will propagate hundreds of meters, if you wish. If you're willing to keep pumping, that's what it'll do. Now, as you're pumping, the fluid is leaking off into the formation, and it's under pressure, so it will drain into the formation. So you will lose pressure that way. But then at the end, you start putting sand or metallic proppant or ceramic proppant into it, and it will fill the fracture. And so when you stop pumping, it'll close on that. That's the principle. Okay. In shales, we believe that what happens is it follows planes of weakness. There are a lot of planes of weakness in shales. So we believe that the fractures may turn 90 degrees. They'll hit a plane of a small fracture, and they'll go that way, and then they'll hit another plane and go that. We don't know for sure, but that's what we think. Because when you look at a microseismic cloud, that's what we think happens.
So in shale, the fracture finds different least
because there's different pieces and parts in the system.
It's not homogeneous. There's no one least.
Right. Because, well, we don't know. We believe there is, but you might see something like this, where these are planar fractures. They will form as planes. So you'll start at the toe, obviously, and work your way back. And you see this one didn't do very well here. The next one, it appears to be breaking. There's all sorts of problems here with monitoring because you have to be close enough to hear it, the microseismic. That's how this works. This is actually picking up the small-scale events with receivers, and then you triangulate back to where these occur. So you can see this must be where the listening point is because there's an artifact that it looks like that. So the listening part must be here, okay, just as an example. But there will be other cases. Let me see if I can go back and find there's a classic vertical well microseismic image. Let's see if we can find it. This is the famous image. And what happened here is you can see somebody drew these in. So this is a vertical well, just like we've been talking about. The well bore is here. And so they started pumping, and they were monitoring all of these. And these dots, they start happening like this. And what you and I believe is that there's a main fracture here, that there will be a dominant fracture that looks like this, all right? What they're drawing here is something different than that. They're taking all the microseismic events, and they said, okay, these over here, that went down a fault. So they think there's a fault over here. We don't know. I mean, I can tell you that when you look at microseismic and you see a fault, boom, it takes everything, because it's a path of least resistance. So, at any rate, we think that what we're getting is a vertical fracture. This is obviously a plan view, like over here. So we believe that we're going to get a main hydraulic fracture that does this. But their argument is there's all sorts of little splinters, and my argument is there's no way you can know that. Somebody drew this in. This is just some artist's rendering of what that looks like. If you want to know, I believe the fractures are going to tend to be planar. Okay? That's what I believe. But I have a Louisiana public school education, so it's hard for me to imagine that rock breaks and twists and turns. Now, having said that, I don't know if that's big enough. Can you see how it's broken up? I don't think you can see very well. Okay, see how this is broken up? This is the Barnett, not the Haynesville. But what happens here is you can see there's planes like this and this and this. Now they believe that these fractures are induced by coring. The actual drilling causes these fractures. The likelihood of you drilling into a vertical fracture is zero. So they think that's what happens. But you have all these other planes of weakness, like here and here, and what I wanted to emphasize is that we want to look at Haynesville core. Okay, I don't know if you can see this very well, it's too dark, but these are all broken up. What's your favorite card game? What the hell is he saying? You're in Texas now. What's your favorite card game in Texas?
Poker.
Poker. All right? So these look like poker chips. Okay? How does rock turn into poker chips? There's a small zone in between that dissolves when you core it. It's made up of calcium carbonate. It's a microorganism. And it bloomed and it died. And it bloomed and it died. And it formed a skeletal fragment between the layers of the shale. And so when they cut the core, it sheared it. So all of the Haynesville core in North Louisiana looks like this. It's all poker chips. So those small layers of calcium carbonate, what had happened with them? When you start injecting high pressure water, what do you think is going to happen? Is it going to break this way, or is it going to break this way, or we don't know? All of our theory says it should break this way, but all of our theory assumes that we have a homogeneous stress field. So you start putting this in, and it just explodes. So you'll see a completely different fracture treatment in the Haynesville than you will in other places because of this nature here. That's why the Haynesville became so prolific. There's a hot spot that this sits on top of as well. So the design of the practical from the theoretical is something that we'll talk about. That's why I bring this in. I want you to understand what's happening. That's the kind of problems that maybe you might want to solve as a practical problem. You want to go to work for Total, right?
Not sure.
Not sure. Yeah, of course. Does Pemex have any unconventional? Little bit. A lot. How much development do they have?
Probably a three nota.
Okay. There's 3. How many wells are there in the American side of the Eagle Ford?
How many wells?
Wells. There's about 4,400. How many are there in Mexico? 3. And they're all on the border. Okay. Why don't you develop your Eagle Ford play in Mexico? Because your money is better spent developing offshore, where you can get 50,000 barrels a day, than going onshore and getting 500 barrels a day. But on this side, we have an infrastructure that 500 barrels a day is a lot of oil, a lot of movement. That's fine. But it's still going to be there, right? It's not going to go anywhere. So 20 years from now, 10 years from now, there'll be Jorge Oil Company, and there may be 10,000 Eagle Ford wells on the Mexican side. But those wells are really expensive, right? And the economics is marginal. Can you afford marginal economics in Mexico? No. You have to have a 10,000 barrel a day well. You can't afford not to. What about in Argentina?
It's huge.
The Vaca Muerta, you've known about it for 50 years.
Yeah.
It has oil, it has gas, and it has condensate. And it's huge. It's not as big as Texas, but it's pretty big.
Yeah.
And 3 years ago, how many companies were there? 0. How many are there now? Probably 30.
Yeah.
It looks like farmland. It's all chopped up.
There are no expectations about it.
Yeah, how many horizontal wells are in the Vaca Muerta?
120.
Horizontal?
Horizontal, I know.
Maybe 3 or 4.
To Vaca Muerta, 120.
Vertical wells, not horizontal. There's very few horizontal wells. Why? Because they got a surprise. It's much more difficult drilling, much more difficult stimulation. And everything in Argentina is vertical wells, so they like vertical wells.
Yes, and also because of the price of gas we have.
How thick is the Vaca Muerta?
How thick?
Yeah. Between 100 and 700 meters. Between 100 and 700 meters. It's arguably the best shale in the world. Maybe except for the one in Russia that we don't know too much about. And some of the ones in China. Who's a big player in Argentina?
Which company?
Yeah, not you, him. Sorry? Sure you do. Total, Exxon, and Chevron. And then a whole bunch of smaller companies. Apache, et cetera, et cetera, et cetera.
How many Canadian companies?
And a lot of Canadian companies. They bought leases, that's right. The point is, this is the future. It's ugly, it's difficult, and it's barely profitable right now. But this is the future. This is where and are we going to talk a lot about this? Not really. Because we need to deal with the fundamentals. But in the spring, we'll talk about this more. But right now, no.
What class in the spring is that?
6:31. Okay. So we've covered all of the things that we're going to do. These are some extra topics, some things you may want to do as part of your project. You may want to bring something else up. What I would ask is that you recognize that we're going to need to solve something relevant to PETI 620. If you come in and you want to solve a production engineering problem that's relevant, that's fine. A drilling engineering problem that's relevant, that's fine. But if you come in and you want to solve an economics problem, that's not really going to fit what we're doing here. Okay. There might be some example that I'm not thinking of that would work for, but I can't think of it. You want to come in and try to solve a chemistry problem. There might be an example of something that would work, but generally speaking, we're talking about the reservoir engineering side and solving reservoir engineering problems. So tomorrow night we meet from 5 to 6:30, and then we go to the party. All right. So everybody happy?
Oh, yeah.
Hmm?
Yeah.
Good.
Who goes to the party?
The party
Yeah.
in the elevator. The party's not in the elevator. The piece of paper tells you. You know? You'll like the party. There's not going to be a lot of girls there, but you'll like the party. Sorry. And just getting you ready for the reality. Questions? Comments? I'm trying to help you to understand what we're going to do here. This is the getting ready part. We start doing the math, bring a pillow. You're going to fall asleep. You know? It's boring. It's tedious. But we have to cover it. We get to the steady state stuff, maybe you like it, maybe you don't. Don't fall in love with the steady state stuff because steady state isn't real. Material balance, maybe you like it, maybe you don't. Material balance is a part of our life because we still do material balance on gas wells or on gas fields, but doing material balance on oil is going to be really difficult. You're going to have very accurate measurements of volumes and pressures. Who performs accurate measurements of volumes and pressures? What company? There is one.
Oliva.
Sorry?
I know a French company called Oliva, which designs thermometers for that. Maybe it's the wrong answer.
Saudi Aramco. Because they use the book that Exxon, Chevron, and Texaco left. And the book says every year, every well gets a pressure buildup. We monitor everything, and that data is good enough to use for things like that. They're not using it for that, but they have really nice data. How many wells are there in Saudi Arabia? Just curious.
Not many, I think.
Probably less than 3,000. How many wells are there in Korea? 2 or 4. How many in China?
I don't know.
Something like 60,000. How many in France? Well,
100?
yeah, it'd be in the hundreds maybe. How many in Mexico?
Probably
Less than 5,000 for sure. Definitely less than 5,000. Mark, where are you from?
Pakistan.
How many?
Less than 100.
Less than 100? Oh, no, it's more than 100. Oh, yeah.
Without that, because of security situation.
No, there's half a dozen companies. There's got to be more than that.
That's my guess.
John, where are you from?
Korea.
So 2 to 4 wells.
Yeah.
How many wells are there in the United States? How many are in Argentina?
I think between 30,000 and 40,000.
Yeah. How many in the United States?
Offered a lot of 4,400, then I'd be able to figure them out.
Anybody want to guess?
10 times China. China is the second.
Yeah, it's approximately 800,000. So something like 350,000 gas wells and 500,000 oil wells, something like that. We'll poke a hole anywhere. There's over 1 million wells that have been drilled in Texas. Yeah, they're not active. Some have been abandoned. Most have been abandoned. They don't have an infinite lifespan. They produce an economic life and then they're terminated. They're plugged and abandoned. So, we're pretty good at this sort of thing. But it's because we don't have high quality reservoirs. We did, but we used them all up. Where are the high quality reservoirs now, Jorge?
Where?
Yeah.
Probably offshore.
What's the largest oil field in the world?
Go on.
What's the second largest oil field in the world?
The one just close to go on.
Is it?
Jorge is smiling back there.
I guess that Qatar is number 3.
Cantarell's probably number 2, but Kashagan is 30 billion barrels, and Tengiz is 30 billion barrels. It's really nasty oil, though, the heavy sulfur. They estimate that Cantarell was 45, but who knows. Do you know what the estimate of the Sprayberry is? This is Dr. Schechter's favorite subject. The Sprayberry. It's in West Texas. It's huge. It's just bigger than guar. Size, not volume. They don't know. They think it's 50 billion barrels, but they don't know. Prudhoe Bay, what, 20 billion barrels, something like that. What's next in Mexico? Cumalabzap? Yeah. What's the biggest field in Argentina? How big? China? I don't know. What's the one they're always talking about? The waxy oil. I don't know. What about in France?
We don't have the right to know.
What about in Pakistan?
I guess it's the sweet deals, I don't know the current person.
So all the easy stuff, where is it? It's all in the hands of the national oil companies. How much of the global market of oil and gas does Exxon control? Less than 2. Less than 2.
Less than 2%.
Less than 2%. ExxonMobil controls less than 2% of the oil production in the world.
And this is a bigger company.
Hmm?
This is the bigger,
It's the largest private company. Saudi Aramco is obviously the largest company. And depending on how you would value Lukoil or Rosneft or Gazprom or whatever, you know, on paper they're basically worthless, but, you know, their assets wouldn't be.
What percentage of the settlement owns
Sorry?
Saudi Aramco is owning which share of the total?
Of the world?
Yeah.
Well, their reserves, as stated, are about 250 billion barrels. Their reserves that they keep on the back books are probably 750 million barrels. Roughly speaking, we're looking at about 1.3 trillion barrels of reserves. That's bankable, that will be produced, roughly. And that number is increasing. It's not decreasing because we're adding more. We haven't had many Kashagans or guars or anything like that, but we've had a lot of little things. So the public doesn't understand that. But the estimated oil in place for the Bakken Shale is astronomical, depending on what you believe. It's 55 billion barrels, you know, but with a recovery factor of 2%. You know, so I mean that's an exaggeration. The recovery factor is probably 5%, but it's you know, these are not going to be plays that using conventional technology will be able to capitalize. We had someone from Venezuela, they would tell you that they've got 3 trillion barrels of heavy oil. Canada probably has a couple of trillion barrels of heavy oil. The United States has a place in Colorado that they don't know exactly precisely the estimate. It varies between 2 and 6 trillion barrels. It's a shale. It is not converted. It did not mature. It has to be heated to give up its shell. And Chevron worked on this. It's called the Mahogany Project. It's the Green River Shale. Why isn't this coming up? Oh, it's waiting. I guess Shell knows I'm trying to show its product or something. What the hell? Why is it waiting on Shell? Is it coming up now? Okay, so what they did is they drilled perfectly straight holes, which we don't do, and they put in situ heaters, and they converted this shale into a product like diesel in situ. It took about 5 years, and they demonstrated that it's viable, but unfortunately the aquifer for that part of the United States is somewhere in here, and the environmental potential for a catastrophe. They developed a way of freezing the aquifer, freezing it, and drilling through it, and they proved that there were no hydrocarbons leaks, no nothing, everything worked perfectly. They spent billions of dollars, hundreds of patents, and it's just sitting there because of environmental concerns. But there's 2 to 6 trillion barrels if you want it. So, at any rate, that's your job. That's why you got into this business. So happy hunting. That's what you're going to be doing. Those are going to be your problems. This semester, this is going to be your problem. Okay. So to get to those, you got to get through me. All right, is everybody happy? Gugu, you feeling better? Or you want to start working problems?
No.
I'm just making sure, because we can play it your way. Yeah. I can have you sit up front and write out all the problems. You follow the technique, right? Yeah, this is going to be fun. I'm going to enjoy this.
You know, not all guys from Polytechnique study the same thing in Polytechnique.
No, I know the genetic profile.
Well,
It's not what you studied, it's what you are. You'll see. So, Maddie, where you at? With the last name like that, you can be the president of Total, right? Yeah. So you have to go to Polytechnique, and you have to have this name. And there's another condition which I cannot say on the recorder. So. He knows. It's still recording, so don't say anything. All right, very good. I enjoyed the night. So tomorrow night we go to the party after we do the lecture. It's hard to get to. Do you not have a car? No, not to there, but somebody can drive. You're going to drive? Who else is going to drive? It's at Veterans Park.
Oh, Veterans, yes, that's on the other side.
Yeah. I can take a couple of people, he can take a couple of people.
How do you see my wife? I got my wife for one ago.
What, do you have a motorcycle?
Now we have a Camry and an Escape.
Questions, comments? Mark, you okay? You just don't like the name. What did you do in your other life before you came here?
I did my undergrad in college.
In Pakistan?
Yeah.
What's the name of the school? News? Nas?
NED.
Yeah, NED. That's
And then I was there at the rig site for around 9 months, and then I came.
rig sites. Let me see your hand. Let me see your teeth. You look okay to me. They're going to enjoy you boys on the rig. Santiago, you enjoy working on the rig?
Yes.
Yeah?
I never stayed too much, going to supervise fracture jobs or acidizing or some
Yeah.
maintenance work.
Yeah, when I was a little boy, my father owned a company that drilled oil and gas wells. And he did not want that for me. So here I am torturing you. Okay, so we'll see you tomorrow at 5. And, dress appropriately for the party tomorrow. I'll let Avery tell you.
Well, it's gonna be hot, and it's barbecue, so.
We're joking.
What that means is, you need to be in a sweater, a tie.
No. Any other questions? What's with all the Macs? Who's using Macs? No, all my wife and kids. Jorge, you happy or sad or
No, I'm happy.
you ready to work?
Yeah.
Gugu, you got anything else on your mind?
But I'm not used to being called Gugu.
Oh, you are now.
I'm used to it, but if you was Gugu in the first place, I think you will make something up.
No, you said that's what...
I was supposed to be Gus. It was Gus, I was Gugu.
You're Gugu. Sorry. I gotta come up with a better name. Pam, Gugu, Maddie, right?
Yeah.
I think I'll just call him Eve. You like that?
It's a girlfriend.
Steve is my second name. When you use the French, you use the line.
You're Dreyfus.
Yeah.
He's the Brewer.
And call me Henry if you want.
That's a good one. I'll call you Ralph.
Wow.
You don't like Ralph.
Yeah, I do. It's my
Favorite name?
grandson's name.
Okay. So what I need to do is I need to write that on your head. Okay. Hold still.
The camera still on?
Yeah, it's still on. Everybody's tuned out. Okay, so tomorrow night we do that, and everybody be ready. The roller coaster is about to take off, so we'll do that and enjoy the time.
I just went down to any of the
What's your about?
yeah, I mean, I just started, I'm only on, like I said, I was on lecture 7. So I'll probably just,
Because last few years I have a more audit and more particularly not going to take class. Everything's available online.
yeah, we get 1,000.
I'm sorry that I bring that
So it's
down,
gonna disappear from
but I had a real problem with that.
and then the other computer lab, you get 300 prints. And I forget what they say, I think they say being double-sided, if that counts as one sheet.
Is that all right?
Yeah, I think, I need to double check.
I'm glad. I don't want to discourage you.
That works? Yeah. Can you just, I already read you some what I own.
No, I'm okay with that. I just need. Very good.
Quick favor to ask, for like 2 seconds, kind of before I officially submit my, not submit, but have you review my resume.
Yes.
I worked on it this afternoon for a while, and I kind of generally was looking at like the areas,
Get rid of all the lines.
get rid of all the lines. Go ahead.
Follow the things, actually.
Okay, that's fine. What I was going to ask then, alright, so I've got your example view right there. So I'll nix the lines and I'll slide it all over. What do I do? Like, I don't have a GPA yet here.
I wouldn't worry about it.
Just
If they just started or something.
Okay. And then I tried to start truncating things, and, you know, my current experience, and I can adjust all these, because I'm a graduate assistant. And one thing I was gonna talk about, I mean, you know, is it important, I mean, and I can try and truncate that more, that expands about.
I think it'll be all right.
Okay. I tried to truncate things as much as I could. These are all older, but I didn't know, you know.
No, it's all fine.
in my
I mean, it's your resume.
Right.
Um,
I just didn't know, I mean, that was from, you know, we're sitting at 2013, and those are from my undergrad and master's before, which
I
were
wouldn't worry about it. I just, so you got a scholarship, or your...
Oh, I guess, oops, sorry. You can just click on it again. I guess I could add my GAT.
No, I would just, this is plenty fine.
Okay.
I just format it in a more simple format.
Okay.
I mean, you gotta realize what companies do is they have a computer program that reads all this stuff and spits it out in text,
Gotcha.
you know, so simpler is better.
I didn't have room for an objective, so I could try and...
No, you got plenty of room.
Okay.
Go ahead and go back to the other format, you got plenty of room. Once
Okay.
you get rid of all these lines, you'll have more than enough room.
Gotcha.
You don't have to use this 1.5 spacing here.
Okay.
And you definitely have your email and phone number.
Yes, sir, I do. And I've kind of gone through, I mean, if there's a cover letter that needs to be done,
You can handle the cover letter,
but I'm not
but
gonna
I would
submit
definitely
it.
just give them the resume. They're gonna lose the cover letter, they're gonna
Right.
lose both of these. if you do that.
Right. Okay. So, yeah, and at the end of the day, did they really care that I'm a licensed in civil? Probably not, but
No, that's a biggie.
it is. Okay. I did all right. I wasn't the highest in my
No,
company,
it
but
doesn't
I
matter. I
did
mean,
well.
it's definitely gonna be a plus.
Wish I could put a GPA on that one. I know it's a pass-fail, but actually, I overstudied for it. I didn't get 100, but I beat the valedictorian in my civil points.
I wouldn't worry about all that.
I know, I'm teasing, but, okay. And then this is a blank right here. I was gonna talk to you, underneath some of this stuff, do you think it would be, you know, talking through courses, or should coursework just come with it, an interview if they're asking about, you know, what I'm gonna cover?
I think what I would probably do,
Because I was thinking, you know, saying, okay, I'm teaching a BBA course.
this you definitely need to do. What I would do is go ahead and, this is not,
Well,
okay, so you got the teaching, and you're not doing research yet,
so it'd be
but
something along the
I
lines
would
of,
probably just say coursework, you know, and then put some.
okay. Are they familiar with it?
Yeah, they'll be fine. You're taking,
Right now I'm taking, 603, year cost 620, and 662. I dropped the seminar because of conflict,
yeah, that's fine.
but, I don't think they...
Yeah, I was, I shouldn't say this, but I was under the impression that they went back and checked to make sure everybody was taking seminar, and they don't. And they stopped doing it a long time ago.
When I put in, I mean, I went through Eleanor and all.
No, that's the right thing to do, but I went and visited with her today, and, because I had a student that had 6 hours of research in that seminar. I don't really cotton to that, because I think people should go to seminar. If you've got a conflict, that's a whole other story, but
I want it, I mean, I always think that stuff's interesting because it helps with you.
it depends on the seminar.
I guess that's
you
true.
know. I mean, we've had squares block salesmen come to the seminar. I'm not joking. We had some pretty low points in our seminar schedule.
Gotcha. No, and I think that all.
Tell me about your work in hydrology. What did you do?
So most of what I did, I mean, my background with regards to like the hydrology work, dealt not with ground flow in practice. I mean, in coursework, I did some aquifer type simulation, but a lot of my stuff was basic routing methods and having the rain come and then looking at some
So these
infiltration.
are like baseball type.
Yeah, more surface.
Yeah, sorry, surface water.
Surface water. So I wish I'd gotten more experience in groundwater.
You're mostly overplaying this right now. I don't think you're gonna have a problem getting an internship. I think you're gonna have a problem getting an internship that's best for you.
Right.
Those grades are gonna open a lot of doors. And
Okay.
once you get this done, I'll send your resume to a couple of folks. I'm not gonna be real thrilled if they hire you, but, you know, that's, super major's great for some things, but, you know, and you may be super major material, but I'd like to see you get some hands dirty type thing.
Okay. Yeah, and, what do you mean you wouldn't be happy if they tried to hire you?
No, I just think, let's say you went to excellent.
Right.
I'm not sure that's what's best for you at this point.
Right.
Although, because what I want to see happen is I want to see you get some formative stuff. But it also, it may not be bad for you because those companies have these huge training focus, and they're gonna, you know, it's not that it's a soft landing, but if you go to a company like, I don't know, name a large independent, a Devon or a Apache or a Anadarko or whatever, you're going to be expected to guide your own training and that sort of thing, because you're going to be expected to know what you need. Exxon, they don't even bother. You're going to go to their schools and you're going to go to their programs and that sort of thing. Shell, something similar to that.
Right, which is where, isn't, with Shell, I mean, with the training, that's where Dake, LP Dake created his.
Yeah, well, I mean, there's going to be things like that, but there will also be probably a lot of we love Shell kind of thing.
Right, please drink the Kool-Aid.
I mean, it actually might be better if you do an internship there, a super major first go around, but the independents generally like to see people they've seen before. And you probably won't get out in May of 2015. Well, let's just see what happens.
And one thought that I had is, I remember we were talking about with McCain with 605, right? Is that the one with where he wants to see 665? Is it only offered when is it offered
It's only offered
in the spring?
You could say it's spring 2015.
Okay. Because another thought is, you know, depending on the course load, if it's really superfluous to be in a 665, I'd like to still cover that material. I always intended on.
I don't know that, you know, I had to tell the Chinese guy that I can't have you in here, I can't have you on the front row if you're not taking a class.
Right.
McCain's not gonna let you be in the class if you're not doing it. Technically, you might be able to pick up the video. I don't know that you can do that. I mean, I put all my stuff out,
Right.
but most people don't, because you have to be enrolled in that class to get to it.
Gotcha.
You're not gonna see the material, in-class material and so forth.
Right.
If you want to try to take 665 and there's a slot open tomorrow, you could probably handle 4 courses, but I don't know if you can handle 4 courses to teach.
Right.
What do
And
you teach?
I'm TAing 301. So it's
I would swap 665 for 662. You could do that.
to get out of 662 and take 665 instead.
That's what I would.
I'm
I'm
thinking.
going to check how he do.
Well, because one thing I was going to
No,
say.
because then it can open up 605 for you.
Okay. For this spring, and then
I
I could
definitely want you in here and I want you in 603. In fact, that used to be the formula that we put everybody through here in 603.
Well, and this,
But I also put people through transport, so I'm not going to do that for you.
what's interesting with this is I'm starting to see the interconnection between, you know, I mean, I've recognized very quickly, even from just reading the production book over the summer, is the diffusivity equation is kind of that fundamental base.
They're not using the diffusion equation for very much. In production, they almost always use pseudo-steady state solution.
Right. That's what she mentioned at Angle.
They ignore the rest of it.
Because I think they're supposed to offer the bigger section for 662 is next spring. I mean, it's in the spring, so I think.
It depends. You know, I'm sitting here thinking strategically, I'm willing to take the risk of what kind of internship you have next year versus where you're going to get the most bang for your buck. If you go to an internship without 662, that's not going to kill you.
Right.
If you go to an internship without 665 and 605, that could, depending on the company, that could be
Right. especially if I'm saying, hey, I would like to do a reservoir type position, if I'm not heavy loaded with reservoir classes.
I mean, I'm thinking of the guys that I know that are, you know, I don't think of them as crusty bastards, or crusty old bastards, I just think of them as crusty bastards.
Okay.
The guy that I'm thinking of right now, you know, well, I remember one time,
It's at -4,
there's a,
first class, so unless they, I mean, if they can physically handle somebody, I could type to Eleanor.
do that in the morning.
Okay, I'll do it first thing.
You cannot drop on Monday, you can only add.
Yeah, I need to get it taken care of then, because if I'm gonna drop 662, or try and handle the load. I mean, I've read through the book for 662, for effectively what we're gonna cover. I have an idea of what we are.
I'm not worried about it. I mean, it's not, you're clearly self-motivated, that's not the problem. The problem is what's gonna suit you for what roles that you're gonna go into.
No, and I agree with that, because a lot of it, if it really ends up just being 2 years, I mean, 2 years goes by fast.
Well, and your internship will knock the wind out of your other work.
Right.
And that's the problem, is that, you know, a good internship has, you know, it's like throwing a boulder in a swimming pool, it really disrupts
Right.
things.
Um,
Unless you're really businesslike about it, I suspect you will be.
plan. Try not to, I usually get focused on something and I'll do it no matter what people tell me. So if they say, you're gonna go into engineering without any credit hours and finish two degrees in 5 years, I did it. It was hell at times, but I did it. So, okay, I'll see if they can squeeze me in. The only other thing I could try and do is if, I doubt McCain, I don't know him well, but is basically say, you know, if you would allow me to watch the videos and read your material and go
Well, we
through
could
the-
ask Ted to mount them somewhere, but I don't know that McCain would let you, because I don't know what he, you know.
There's room in the distance courses, but I don't think they would let me take it as a distance course.
That's a really good point.
I mean, there's space in the distance, there's just not the physical. I can watch the videos just as well as I can be in the lecture.
That's really good. I wonder why they wouldn't let you do that.
And then basically,
You could ask Bill.
and effectively, it's like, well, the only way to ask questions is via, email.
He's not gonna answer your questions. I'm not gonna answer. I mean, I'll
Right.
answer email, but I'm not going to chat with you guys.
No.
That's a
So-
really good idea. I wonder.
They might not desire that because of that, but if there were open spots.
Your Texas residents, they can't do
I'll
that.
ask.
I mean, I'm really serious. I'm sitting here thinking, how can you deny a Texas resident?
Course and, access into a course.
Now, we're paying for your courses by the GAR, or